We are going to begin our new unit, ratios and proportions. I think after doing our algebra unit, I think you will find this a little bit easier, and I think some of you will like it a lot better. So just like with everything, before we begin, we need to get some definitions down so we're speaking the same language. Our first definition is ratio. A ratio is a comparison of two quantities using division. So I've written the definition, and you can pause this and write the definition as well. A ratio looks like a fraction, and so here are some examples of ratios, and I know you've seen these last year with Mrs. Whetstone. And we're going to talk about how to write them in just a second, but there are some examples of ratios, and when we are talking about ratios, we say 3 to 4. So how that's written the second way, 3 to 4, that's how we say it out loud. Even if it's written as a fraction, or even if it's written with the colon mark, we still say 3 to 4. Our next definition is rate. A rate is a ratio of two quantities with different units. Some common examples are miles per hour. So if you go 60 miles in 2 hours, that's a ratio of two quantities, and they have different units. One unit is miles and one unit is hours. Another example is when you shop, like for fruit or grapes, price per pound, so dollars per pound. So I'm comparing two quantities, and they have different units. My top unit is money, and my bottom unit is weight. A unit rate is a rate with a denominator of 1. So if we look at that example, this example right here, if I go 60 miles in 2 hours, a unit rate is how far do I go in 1 hour. So if I go 60 miles in 2 hours, I would go 30 miles in 1 hour. So notice how I have divided both the top and the bottom by 2, and I have a denominator of 1. So, and the reason we like unit rates is that makes it easier to compare. If our denominator is always the same, 1, it makes it easier to compare things. So that's why a unit rate is important. How do you write a ratio? We've already talked about this. We can write it so it looks like a fraction. We can write it with the word 2, 3 to 4, and we can write it with a colon so it looks like that, 3 to 4. And they all mean the same thing. It doesn't matter how you write it. So each one of these mean the same thing. And when we're talking about ratios, we say it as 3 to 4, no matter which way that it's written. That's how we say it out loud. Simplifying ratio. Ratios should be simplified. And the reason for that, it just makes it easier to compare. And our example is that same example, the 60 miles every 2 hours is the same thing as 30 miles in 1 hour. Sometimes when you're asked to find a unit rate, it may not say find the unit rate. Unit rates are expressed in other ways. Sometimes it will say find the average speed. And sometimes it will say what is the best buy. And when you're asked to find the average speed or the speed or best buy, they're just asking you to find the unit rate. So denominator of 1. And this part right here is just kind of a hint for you when you do your homework. because you will see some problems like that where it says find the average speed or find the speed, what is the best by, and they're really just asking you to find the unit rate. So denominator of 1, that's what, when it asks for any of those things, denominator needs to be 1. And I would make myself a note like I'm doing here. When it's at a unit rate, average speed, best by, denominator needs to be 1. And if you can remember that, that will make some of your homework problems easier. All right, a complex fraction has at least one fraction in the numerator, denominator, or both. So I'm going to go ahead and write the definition. So there's the definition. You have worked with complex fractions before. Now that we're using calculators, it makes it a little bit easier to simplify. But here is what some examples of what complex fractions looks like. So you might have 1/2 divided by 3. So my numerator has a fraction, and then my denominator is just a whole number. Or it might look like this. So my numerator is a whole number, and then my denominator is a fraction. Or it could look like this. So my numerator is a fraction, and my denominator is a fraction. So that is what a complex fraction is. It has at least one fraction in the numerator, which is our first example, or it has one fraction in the denominator, which is our second example, or it has fractions in both the numerator and the denominator, which is our last example. And so you know how to solve those. We've done those before in our very first unit, and like I said, with a calculator it makes it a little bit easier. So let's look at some examples of finding ratios and rates and how we write them. Our first example says there are 45 males and 60 females in a subway car. The subway car travels 2.5 miles in 5 minutes. Part A says find the ratio of males to females. When I do ratios, I always give myself, I call it a little cheat sheet. So over to the side, I write what they're looking for. So it's asking for the ratio of males to females, and I write it exactly how I see it. So males to females, males is on top, females is on bottom. So I look at my problem, there's 45 males, and there are 60 females. So there's what my ratio would look like, 45 males to 60 females. And if you want to write it as 45 to 60, that's fine too. I don't care how you write it. I usually write mine so that it looks like fractions because that's easier for me to simplify. 45 to 60 simplifies. I know that I can divide 45 by 15 and I can divide 60 by 15. And so when I simplify that, I have 3 males to 4 females. So this would be my answer. All right, then the part B says find the speed of the subway car. Speed is unit rate, and we just talked about that in our definitions. So when we talk about speed, we're always talking about distance to time. Time is always on the bottom. So it says that it goes 2.5 miles in 5 minutes. All right, so I want my denominator to be 1. When I'm talking about speed, that's a unit rate. I want my denominator to be 1, so I need to divide this by 5 to get a denominator of 1. If I divide my bottom by 5, then I also have to divide my top by 5. And I can do that on a calculator. 2.5 divided by 5 comes out to be 0.5 miles. And you might want to check that, so you might get your calculator and check that. Don't just take my word for it. So I go 0, or the subway car goes 0.5 miles in 1 minute. So what that means, if we wanted to write it so Miss Bernowski would understand it, so the subway goes half a mile. 0.5 miles is 1/2 a mile. And if you want to write 0.5, that's fine, every minute. So either way, both of those answers are fine. All right, my example 2 says finding a rate from a ratio table. The ratio table shows the cost for different amounts of artificial turf. Find the unit rate in dollars per square foot. So here's my amount and my cost, but I am supposed to find the unit rate in dollars per square foot. So dollars per foot squared. That's how my ratio is going to be. And if you make yourself a little note, whenever you're talking about a Best Buy or whatever, money always goes on top. That will help you get the right answer, but it's something that I just remember, and then I don't have to really think about it. But money always goes on top of your ratio. All right, so now let's look at that. $100 for 25 square feet. That simplifies. I can divide the bottom by 25 and the top by 25. That simplifies to $4 per 1 square foot. All right, so I just happened to use the first numbers in the table, but what if somebody else used, say, 1,600 over 400? Would you get the same answer? You can divide the bottom by 400 and the top by 400. So you get $4 per square foot. So it doesn't matter which one you use in the table. If you use the first one and your neighbor uses the third one or the fourth one, you should still get the same answer unless you have a math error. And sometimes you won't. We'll talk about that later lessons about why you might not get the same answer. So it doesn't matter which numbers you use in the table, you should still get the same answer. You have some examples to do on your own. So go ahead and do those examples. I will do them as well, and then you can check your answers. So in the first example on your own, it says find the ratio of females to males. Notice I made what I call my little cheat sheet. So I'm supposed to find females to males. Females are on top and the males are on bottom. From that first example, females were 45 and then males were 6, I have that backwards. Alright, so I had mine backwards, but females to males is 4-3. And notice how I made my little cheat sheet, so I know which goes on top. Females goes on top, and then males goes on bottom, so 4-3. Then in my next example, it says find the ratio of females to total. So I had 60 females, and then my total passengers would be 105. And that simplifies to 4-7. So I have 4 females to 7 total passengers. And then the last example says the ratio table shows the distance the International Space Station travels while orbiting the Earth. Find the speed in miles per second. So my cheat sheet is going to be distance and then time on the bottom. And I will just choose the first one. You don't have to choose that one. But when we're talking about the speed in miles per second, it's already telling you that the unit, it wants a unit rate because it wants it in 1 second. So I'm going to divide the bottom by 3 to get 1, which means I have to divide the top by 3. 14.4 divided by 3 is 4.8 miles per second. And again, it shouldn't matter which one you use in the table, you should get 4.8 miles per second. If this does not make sense to you, or if you have, we have one more example. Let's do our last example. Alright, it says, you mix half cup of yellow paint for every 3/4 cup of blue paint to make 15 cups of green paint. How many cups of yellow paint and how many cups of blue paint do you use? So, I have yellow to total, and I have half a cup This is where I'm going to use complex fractions. And then my total is 1/2 plus 3/4. So that comes out to be 1/2 divided by 5/4, or 1/2 yellow paint to 5/4 total paint. And I can divide that on a calculator, and when I work that out, then I get 2/5. So 2/5 of yellow paint. So what I need to do is I use 2/5 times the 15 cups, which means 2/5 times 15 cups is 6 cups of yellow paint. And then for the blue paint, I can do this same process with fractions all over again, but I know if I have 15 cups total and 6 cups is yellow, then I know 15 minus 6 is 9. So I need 9 cups of blue paint. Alright, then on your own, it says how many cups of yellow paint and how many cups of blue paint do you use to make 20 cups of green paint? The fractions are going to be the same, so I've already worked through that part with the yellow paint. So I'm going to take 2/5 times 20, and this is yellow, and that comes out to be 8 cups of yellow paint. And then to get the whole thing, 20 minus 8 is 12. So I would need 12 cups of blue. That's really kind of a level 4 example. So if that example doesn't make sense, that's okay. Just because we're using some things from our previous Unit 1 when we were doing our number system. So that's kind of a level 4 example. If that doesn't make sense to you, come see me in the morning and I will help you get it figured out.